Hello, everyone. Welcome to SciLine's media briefing on extreme heat. I'm SciLine's director, Rick Weiss. And for those of you not familiar with us, SciLine is a philanthropically funded, editorially independent, free service for journalists and scientists based at the nonprofit American Association for the Advancement of Science. Our mission is pretty straightforward. It's to make it as easy as possible for you reporters to get more scientifically validated evidence into your news stories. And that means not just stories that are about science, but really any story that can be strengthened with some science, which in our view is just about any story you can think of. Among other things, our Experts on Camera service lines up scientists who have research expertise in topics in the news, makes them available for personalized one-on-one broadcast quality interviews with you. Just go to SciLine.org, search for Experts on Camera, and while you're there, check out our other helpful reporting resources. A couple of quick logistical details before we start. We've got two panelists today who are going to make short presentations of maybe 5 to 7 minutes each before we open things up for live Q&A. To enter a question during or after these presentations, simply hover over the bottom of the Zoom window, select Q&A. Enter your name, news outlet, and your question. And if you want to pose that question to a specific panelist, be sure to note that. A full video of this briefing should be available on our website by later today, and a time-stamped transcript within a day or so after that. If you'd like a raw copy of the recording more immediately, just submit a request with your name and email into the Q&A box, and we'll get a link to you by the end of today as well. You can also use the Q&A box to alert SciLine staff to any technical difficulties. Okay, I'm not going to go into full introductions for our two speakers. Their bios are on the SciLine website. I just want to tell you that we will hear first from Dr. Andrew Pershing. He is Vice President for Science at Climate Central. Climate Central is an independent research organization that studies and communicates about climate science. It actually is a sort of a sister organization to SciLine in many respects. Like us, it is comprised, it comprises scientists and journalists and other science communicators together with the goal of helping journalists and the public understand climate issues. As the group's director of attribution science and climate fingerprinting, a title I love, Andrew will talk about how climate change is contributing to heat waves, how our quantification of those impacts is evolving, and what U.S. communities like those that you are living in can anticipate for the rest of the summer and in the next few years with respect to extreme heat. Second, we're going to hear from Dr. Christy Ebi, a professor at the University of Washington's Center for Health and Global Environment, where she conducts research on the health risks of climate change. She's going to focus on the impacts of heat on physical and mental health, with some emphasis on demographic populations that are most at risk, and she'll discuss some practical strategies for surviving these increasingly frequent and intense temperature extremes. Okay, so I'd like to get started, and why don't we just get going with Dr. Pershing.
All right. Hello, everybody. It is great to be here, and I really appreciate the invitation from SciLine, which, as Rick said, is an organization that is a great collaborator and sort of a sister organization in many ways for Climate Central. So I'm going to give an update on some of the things that we're seeing this summer, which is, I think, heat is in everybody's mind. We're seeing heat events popping all over the world, and especially here in the United States. And so it's a really good time to think about how do we track heat events? How do we connect them with climate change? And what is the future likely to hold? So first question, I'm going to start with kind of 3 grounding questions. So the first question I'm going to start with is, how do you define hot? It's actually a thorny question. And so one of the ways, of course, is just absolute temperature. And I think this is perhaps the most common one, and one of the most common ones that you see in the media. And that's defining it in the sense of, like, what would the temperatures be that would stress a healthy adult? I think everybody looks at Phoenix, 115 degrees, and can say, man, that's hot, right? That is going to be a stressful temperature that would stress just about everybody. And so I think there's a natural tendency to want to focus on those extreme absolute temperatures. And if we were talking globally, we talk about, some of the cities in the Middle East. But relative temperatures are also important. temperatures that are unusual for a location, right? Warm relative to what the baseline would be at that location for that time of year. And those are important because those are temperatures that are going to be stressful to people, right? Because of how we've adapted either our physiology or our technology around us to be able to deal with that heat. But it's also going to be stressful to plants and wildlife. And I think this is something that doesn't get, has not been covered a lot this summer. Ecosystems have adjusted to the range of temperatures that that they've experienced throughout history. They're now encountering temperatures that are beyond historical precedent. And so those are the kinds of conditions where you're likely to see ecosystems start to come under stress. Okay, so we can look at temperature anomalies, which is you take the long-term average and you subtract it from what you've observed. And so this is the average temperature anomaly averaged over the month of July for North America. So you can see, in the Southwest, not only does the Southwest have high baseline temperatures, right? We're now adding 5 to 10 degrees on top of that. And so that creates these very stressful conditions, right? It pushes us into that extreme zone. But you can look at places up in the Arctic where we have very intense temperature anomalies going on right now, or at least going on back in July. But the baseline temperature is lower. But you might actually expect that these temperatures may have a bigger impact on the ecosystems there because it's so much greater than the baseline. Okay, the second question is, how do you quantify whether a particular temperature has been influenced by climate change? We developed at Climate Central a system that we call the Climate Shift Index. It's a way of quantifying every day whether climate change is having an influence on that day's temperatures. So it's a form of climate change attribution, and we've automated it, and we're doing it every day, everywhere around the world. It allows us to say whether a day's temperature was made more, or in some cases less likely, by human-caused climate change. And we use the scale that I'm depicting below, which goes from -5 to 5. 5 is the highest number. It means 5 times more likely or more because of climate change. So we can do this every day. So here's just an animation that we have on our website for every day in July. You can see the red and yellow colors that sweep across the country and really settle in the south and southwest over the month of July. And so we're doing this every day. And then what we did is we then averaged them up. And you can see that in the Southwest over the month of July, they were at that level 5, 5 times more likely because of climate change, basically every day. But you can also see that while it's very unusual, the temperatures that we're seeing in New Mexico and Arizona, we also see these strong, what we call climate fingerprints down in Central America, in the Caribbean, and in Florida, places that have not received as much attention, and also up in Canada. So we can, if we break down the map here a little bit, Southwest and Northern Mexico have gotten a lot of attention because it's unusual and because it's extreme, right? Extreme in an absolute sense. Then we have places like Florida and the Caribbean that also are very, very warm and unusually warm, and where there's a very strong climate signal. Central America and the Gulf of Mexico, including Louisiana, and then Western Canada, where that was the big story early in the year, back in May, when we were seeing the fires get started. That area is tended to have a strong anomaly throughout most of the summer. And then we can go to specific locations. So in some of our reporting, we've been highlighting San Juan, Puerto Rico. Cape Coral, Florida emerges as an area that has had very intense climate fingerprints in July. Mesa, Arizona, Albuquerque, New Mexico, and Baton Rouge, Louisiana are all places that stood out in our analysis. Okay, so just to sum up, where do we go from here? Well, we can think about that in a couple of different timescales. So first, over the near term, meaning the next couple of weeks, NOAA is predicting that a lot of the places that have been unusually warm are going to still be unusually warm. And this is one of the kind of really interesting features of this summer, is how persistent the heat is in many of these places in the country. On the longer term, one of the things I want to emphasize is that this is not the new normal, right? Normal implies that it's ordinary, right? Or that it's natural, and it's very much not, right? Our analysis shows that climate change is having a detectable, quantifiable impact on the day's temperatures. And it's also not normal in the sense of something that we can get used to, right? I think when we talk about new normal, we talk about like a baseline that like you now can get adjusted to that baseline. That's not going to happen because every year we expect to get warmer and warmer. And that's what it means to live on a warming planet. And the future depends on us. And you can see this in a few cases. Here are 3 cities. Here's our graphics that we put together for one of our Climate Matters releases last year, just showing the projected projections for, in this case, Newark, Chicago, and Phoenix. The red line at the top is what we expect to happen under continued emissions. The lower line is what happens with significant cuts. Think about, full implementation of a net zero strategy everywhere in the world. You can see that temperatures warm and then level off. You can express this in a different way. We do this by an analysis that we call shifting cities. So by 2060, Newark is likely to have the climate that Charlottesville in Virginia currently has. And by 2100, under the high CO2 scenario, might feel like Augusta, Georgia. Chicago, moves south, might someday feel like Montgomery, Alabama. And then Phoenix, poor Phoenix has to go to El Mubarak in Saudi Arabia, right? You really are having to jump to a very, very different climate than what Phoenix currently has. So we have a bunch of resources that you can use to help talk about this story. We did a fairly deep report on the temperature situation in the US and around the world for July. We also have our climate shift index map where you can see that climate shift index score for today and back in the past. And we have some of the resources I showed around US projections in shifting cities. And if you haven't signed up for our Climate Matters bulletins, please do so. They're free, weekly package of materials to help you cover climate change. And then we also have alerts that are also free where we'll tap you on the shoulder when there's something interesting going on in your location. So thank you.
Fantastic, a really rich presentation. Thank you, Dr. Pershing. And yeah, one of the things Climate Central does so well is using graphics and just being able to see sort of what your city is going to be like in 20, 40, 60, 80 years is a really interesting approach to trying to drive home what we're really talking about here. Okay, let's move on to a little bit of the health angle with Dr. Eli.
Yeah, thank you very much. And I also want to thank Andy. That was just a great presentation. And it's my job then to say, so what does it mean for us? I don't have nice graphics, but I have words and I've got references where you can go and find some nice graphics. The headline statement is people are unnecessarily suffering and dying from the heat. That, as I'll explain on this slide and the next one, there's deep understanding of how heat affects our bodies. And there is deep understanding about what needs to be done to protect people during hot periods of time. And therefore, all heat-related deaths are potentially preventable. And thank you, really, for covering heat as a critical issue, because one of the challenges we face is the very low awareness about heat as a health risk. I spoke about mortality. When we think about periods of high temperature, there's also impacts on occupational health and productivity. We know there's increased sports injuries and illnesses. There's adverse pregnancy outcomes. The list of the most vulnerable during a heat wave is quite long. Adults over the age of 65, people who've got chronic medical conditions, people who work outside, pregnant women. The list goes on. And so there's lots of people who need to be paying more attention, need to be motivated to make some changes during heat waves. But unfortunately, a natural part of the aging process is people become less well able to tell they're getting into trouble with the heat. So even if they know that it's hot outside, they don't necessarily make changes in their behavior that would help prevent heat stress. When we think about the impact of heat on our bodies, we focus on our core body temperature. This is not the temperature you measure with a thermometer. This is the internal temperature in our body. And that needs to be maintained within a pretty narrow range to protect ourselves and our organs. I'm often asked, what is that core body temperature? First of all, it's not terribly used because people don't know what their core body temperature is. But second of all, there's lots of factors that increase or decrease the core body temperature. So it's not just heat, but we have to think about our infrastructure. We have to think about the behaviors people undertake during a period of hot weather. It's quite hot. People go and find a shady place to be. They find some place by the water to cool down. So there's lots of ways that people can help keep that core body temperature down. And I'll make the point again, it doesn't have to be with air conditioning. We know from the Lancet countdown that exposure to heat waves has been increasing. I have the data here for 2020. These are worldwide data that adults over the age of 65, a group at particular risk, there were 3.1 billion more person days of exposure over the long-term average. On the right is a summary about the spectrum of heat illness, going everything from heat rash all the way to heat stroke. Heat stroke is a medical emergency and requires immediate medical intervention. And even with medical intervention, the mortality rate is high, and people who survive heat stroke often have lifelong consequences. Another key point is that heat-related mortality is significantly underestimated. When you look at the official numbers, it's about 700 Americans die every year from the heat. There's a couple of studies that have modeled using the kinds of approaches that are being used for COVID, of looking at the number of excess deaths. And one particular model estimate was 12,000 annual deaths. So this is a big impact right now, and of course is anticipated to get much worse with climate change. When we talk about heat and health, we need to think about inequities. There's lots of ways that heat exacerbates current inequities. You think about where people live, think about the red line districts. Those districts are hotter than surrounding areas. They don't have trees or have fewer trees. And so there's lots of interactions between heat and inequity, and very pleased to see increasing coverage of that. There's been coverage, of example, for farm workers and how the heat really exacerbates the inequities that they already experience. And there's lots of ways to protect individuals and communities. Heat wave early warning and response systems save lives. We know that they work. There's not enough of them, and for almost all of them, including some of the very good ones in the US, there's ways they can be improved. Thinking for the longer term, a heat action plan also incorporates thinking about our infrastructure. I live in Seattle. You go downtown, there's cranes everywhere. We continually rebuild. And thinking about what the building codes are going to be. Are you going to require every building to have a white roof, building over a certain size to have a green roof? And so thinking about that longer term planning so that you have the short term emergency heat wave and response system, and you've got the longer term planning. When we look into the future, the magnitude and the pattern of the future health risks are going to depend on the extent of both adaptation and mitigation. In the short term, on the adaptation, the heat wave early warning systems, education and training, lots of changes to be made to increase awareness of the health risks of heat. And I have some numbers here from the study that modeled the 12,000 annual deaths projected at the end of the century. Without adaptation and mitigation, there could be an additional 100,000 or so deaths from heat without taking action. And so overall, there's urgent requirements for investments in research and in risk management. And the third perspective I want to add is to think about heat as an all of society problem. I'm focused on the heat. You can see on the slide how heat interacts with the inequities I spoke about in affecting people. We also need to think about environment. We were talking before you joined about what's going on in Hawaii right now. You have periods of very high temperatures. I live in the Pacific Northwest. That goes along with drought, that goes along with wildfires. That affects air quality. And so you get these compounding and cascading risks that affect people, but also affect livelihoods. Think about the Pacific Heat Dome 2 years ago. We can talk about the number of people who unfortunately died in that event, but you can also think about between Seattle and Vancouver, BC, during low tides, the temperatures were so high about 1 million mussels, clams, and oysters were cooked. That's food security for coastal tribes.
Mm.
And on the right, you see the infrastructure, our urban heat islands. We're seeing power disruptions with high temperatures. And thinking about all the different ways, as I mentioned in the heat action plan, we need to interact in terms of how we're going to improve our long-term infrastructure, how the planning is going to be for our long-term infrastructure to make sure that we're going to have cities that are going to be more comfortable as temperatures continue to rise. With that, I look forward to answering. Oh, I have one more slide, sorry. So these are some selected resources that we can leave up. We can give you the slide, but here's some places where you can go and look up some of those numbers and get a little bit more information. And with that, Rick, back to you.
Great, and I'll remind reporters on the call today that these slides will be up on the website immediately at the end of the briefing, so you can look at those resources and more. And also, if you have questions, you can start putting them into the Q&A box, and we'll start getting to those now. I do like to start these briefings with one question from the moderator first, so I'm going to do that, and it's meant to be as helpful as possible to the reporters who are on the line covering this beat. And I'd like to ask if each of you could briefly address the question of, in what ways, from your reading of the news as experts in this area, are you either happy and satisfied, or maybe wish there were improvements in how reporters are covering the extreme heat beat that is now becoming so important in journalism? And Andy, I'll start with you.
Yeah, thanks. I read the paper and I get sort of shaking mad when I see a story that talks about heat and doesn't mention climate change, because it really is one of the easiest connections to make. And so that's partly why we developed the Climate Shift Index system, because it is a way to actually quantifiably say that climate change is playing a role in a particular day's temperature. So I think that's kind of that's one of my things, although I would say that I've seen the media do a better job this summer than in the past. I think there are a lot more stories that make that connection between the extremes and climate change. And then, I think there is the other thing that I would love to challenge the community on is, Phoenix. I get why we focus on Phoenix. I get it, but there's a lot of unusually warm temperatures around the country. And those temperatures are stressful to the people and plants and wildlife and pets and families living in those areas. And so there's a lot of local stories around heat that can be talked about. It doesn't have to be 115 for really bad things to start to happen.
Great point. Great reminders. Thanks. Chris, how about you?
I'd like to follow on Andy's comments and be slightly more positive. I take on board and I completely agree with all of his points. There's really low awareness that heat is a health risk. And the stories, until quite recently, just kept reporting temperatures, but didn't really say, so what? What does it mean? And that is starting to shift. And we have to really get to a place where people understand that heat is a risk. The way I've been thinking about this recently is it's hard because we love the summers. We all look forward to summers, and part of it's the warmer temperatures, it's the longer days. And how do you communicate that heat is a risk but it's something you like to do too. You like to go out when it's warmer. And I was thinking an analogy is boating. People love to go out on water, and you wear a life vest. And thinking about ways to help communicate, enjoy the summer, enjoy the temperatures. And there's going to be periods of time where people really are going to have to protect themselves because we're just not built physiologically to manage these very high temperatures and the consequences we're seeing in the emergency departments and in the morgue.
Yeah, it's interesting. I wonder whether the reporting of deaths may have to get more explicit to help the media recognize that many of the deaths that are heat related or heat caused actually are. I'm not sure that's always listed as the primary cause of death. We can get into that a little bit, but it looks like not. Okay, I do want to start getting to questions from our reporters. We have quite a few, so let me just jump into that. And I'll start with a question from Noah Glick, who's from the Sierra Nevada Ally. I'm generally curious, is there an area in the US where we see impacts of climate change not happening in such stark terms here, where are the future habitable places? So I'm not sure if this is meant to be a real estate question about, where to go next, or a climate question, but are there places where it looks promising for one reason or another?
That's a really interesting question. There have been a number of analyses that have tried to take that on. I'd say it's a challenging thing, and really there is nowhere on the planet that is not feeling the effects of climate change. And it's really more about like which of the effects that you think you might have a better shot at adapting for, preparing for, having, being somewhat resilient to. Within the United States, certainly in the summer, a few places that stand out, kind of the northern Great Plains, northern Midwest, stand out as having had less warming than other areas. That's not a robust prediction from the climate model, so they're definitely just kind of lagging behind. So I would say that's an area that would be easy to say seems safe right now, but probably is not as safe as it appears.
Great.
And the piece I would like to add to that is there has been emphasis in the news about livability, survivability, habitability, which are all different, by the way, but we don't need to get into that. And it only focuses on temperature, but it just matters critically what our infrastructure looks like. People live, from my perspective, in pretty crazy places around the world. People live in Antarctica. Humans are pretty good at living in places that just looking at the temperature, you'd think that's not possible. And so when you ask those kinds of questions, it's also how we think about our infrastructure, how our infrastructure is changing, how it needs to change, so that cities can be comfortable as the temperatures continue to go up.
Great. Okay, question here from Henry Schwann at the Telegram and Gazette in Worcester, Mass. Why was New England not hit with extreme heat this summer? Lots of rain, relatively mild temperatures.
So if you look at maps of temperature, especially if you look at maps of temperature anomaly, and you watch them in a movie, it's a lot like looking at a lava lamp. You see these sort of bubbles come up here, and things go down there, and that's because the atmosphere is a fluid. So one of the consequences of having a big heat dome in the southern part of the country is that there has to be a yin to that yang. And that's been New England, and that New England tend to be a little bit cooler because it's sort of kind of the other side of that heat. And so you can almost think of like three kind of cells in the country across North America right now: Western Canada, South Central part of the United States, and then Eastern Canada. And New England is kind of stuck in between two of those, so it's going to be a little cooler.
Interesting.
Yeah, and I live in Seattle. We've also been incredibly fortunate. And as Andy said, we were just lucky. It doesn't mean we're going to be lucky next year, but this year we're lucky, and I very much feel sorry for all of the people who are being affected. And thank goodness it's not everywhere at the moment.
Sounds like not a ticket to long-term good luck, though, so that's good to keep in mind. Question here from Sean Goodwin from the Idaho Statesman. Would you be able to speak to how climate change and heat have played a part in the Maui wildfires?
Yeah, a great question. So we have started looking at that event. And I have to say, I'm not fully up to speed on exactly kind of the meteorological setup. Just from looking at our data, August 7th and August 8th, and Maui and the Big Island were both warmer than normal, and we had a discernible climate fingerprint. I believe they were at level 2 on our scale, so 2 times more likely because of climate change. Fire is super complicated. Heat is only one of the things that you have to have. The winds were really, really important for these fires. The wind patterns were very much driven by the hurricane that was, or the hurricane Dora that was passing to the south. And so that you could also, bigger, more, larger hurricanes are more likely in a warming planet. And so that may also be contributing. So I'd say there's there's evidence and we can see little threads, but it's one where I think you really would like to see more research and kind of somebody to take a really a much deeper dive.
Great.
And Andy, you could add to that, though, that there's many places where there are climate fingerprints for wildfires.
Absolutely. Yeah, no, the Canadian wildfires this summer were very clearly kind of, came on the heels as the unusual heat moved across the country.
Okay, great. Question here for Dr. Ebi. This is from Aubrey Uhas from New Orleans Public Radio. I cover K through 12 education in Louisiana. Other than guidance put out by Arizona's health department for schools, I haven't seen best practices for K through 12 and child care providers from health agencies when it comes to heat. What policies should schools be following?
Excellent questions, and really impressive work being done in Phoenix and Maricopa County around communicating around heat. In thinking about school children, there's a couple of places to look, because I don't know the answer on the best practices. The first is heat.gov, and that's through NOAA, and it's in the resources I put at the end. And it provides all kinds of resources. There were multiple discussions over the last several years about how to communicate about heat to K through 12. And I don't know if that's on the website, but there were discussions around that. The second source is the Corey Stringer Institute. He was a Minnesota Viking football player who died from the heat. And it illustrates, number one, the challenges of how hard it is to tell when somebody's getting in trouble with the heat. When you've got a professional football player surrounded by a bunch of people paid a lot of money to protect them. He unfortunately did die from the heat. And as part of the settlement, an institute was set up in his name. It's on the East Coast. I think it's either in Connecticut or I think it's in Connecticut. Andy, are you looking that up? See, you're typing away. We can put that up for you. And initially, the institute was focusing on professional players and protecting professional players from the heat. But I know they've expanded to university sports, and I know they've done work around high schools, and that particularly for sports activities, being outside in hot weather, that would be another source that might be quite useful in your coverage. And the people there are just wonderful to work with. Yeah, it's the Corey Stringer Institute.
You're muted, Rick.
Thank you. Question here from April Reese at Searchlight, New Mexico. Are there any particular cities? This is not about where people should move. This is about who's doing a good job. Are there any particular cities that you think are doing a good job at preparing for and responding to increasing heat? This can be a great way for reporters to sort of show by example.
And I can start on that, if I may. There's lots of heat wave early warning systems around the US and worldwide, and many of these are very good. There are now 3 cities, if I'm correct. One is Phoenix, Maricopa County. The second's Miami, and the third, I think, is Los Angeles, where the cities have named heat officers. And it's the job of these individuals to coordinate across the whole range of services you need to coordinate when you have a heat wave early warning system. The heat wave early warning systems are not necessarily complicated. They do require a lot of coordination, because you start thinking about who should be at the table. You need, of course, your EMT, the police, the fire department, who looks after elderly care institutions, who goes out and works with the unhoused, who speaks to the red line districts. And you start going on and realize it's a really massive coordination effort to try and keep everybody aligned, make sure that the services are available, information gets to the most vulnerable. So at least those 3 cities are in some ways ahead of the pack, because they have these heat officers. But there's also really good heat wave early warning systems. The first one started in Philadelphia. There's systems in Detroit, in Washington, D.C. I don't know all the places they're located because there's no tracking of those at the moment. But there's lots of really good examples that can be drawn upon.
If
Andy?
reporters want to find what's going on in their own city, is there a certain department within city government that typically would be where they'd want to look to find out?
I would start with your emergency management and whatever, in Seattle, it's the disaster risk, maybe it is the emergency management department, but every city has some kind of emergency management department. And I would start there. You can also look at the Department of Health, because the Department of Health would be engaged with anything that's done around a heat wave early warning system.
Andy, did you want to add anything to this?
No, it was fantastic.
Okay, great. Here's a question from Deb Kroll at the Arizona Republic. We've been reporting on all this for years, and one thing I hadn't noticed is the speakers discussing is the role of high-low temperatures, that is high temperatures even at the coolest parts of the day or night, and how that plays a role in heat illness because the body never has a chance to cool down for part of the day. What resources would you suggest for those on this call who don't already have awareness about that? I've certainly seen that talked about in environmental issues, that the lack of cooling temperatures at night have contributed, among other things, to wildfires. But I haven't heard much about that in health. I agree with Deb.
Actually, I've had quite a few reporters call and ask me about that question specifically over the last month. And you're absolutely right. If we go back to the core body temperature and you think about your day, as you go through the day and the temperature goes up during the day and hopefully comes down at night, that core body temperature fluctuates. It increases, it decreases, and hopefully you get the respite at night to really get that core body temperature down. When you look at a heat wave, the mortality starts within about 24 hours. So people don't start dying immediately from a heat wave. It takes about 24 hours for that heat to build up internally and then to start affecting our cells and our organs. That period at night is critically important, and there's quite a few studies in public health literature that document that high temperature at night increases mortality. It just increases susceptibility of people to impacts on their organs from high internal temperatures.
And I would just add that there is a strong climate fingerprint in nighttime temperatures. It's even easier to see the influence of climate change at night than it is during the day. And some of the overnight temperatures, the low temperatures we're seeing in the Southwest this summer are just really, really amazing. I mean, shockingly high. And that's very much a part of climate change.
Right. Question here from David Borax from WFAE Public Radio in Charlotte. Most states and the federal government do not have heat exposure standards for outdoor work. Can you comment on whether that's warranted and what we know about places that have them? Chris?
There are 4 states that have regulations out of 50 for outdoor workers. It's the 3 Western states and Minnesota. And they're all a little bit different, but because of the very high risks of people working outdoors, they save lives. This is one of the places where we understand the physiology, we understand how to get people's core body temperature down. It's pretty straightforward. And if you can protect workers and keep those core body temperatures down, it's helpful. It really does save lives. There's been lots of coverage of outdoor workers who've died from the heat. There's some lawsuits now from families of outdoor workers who've died from the heat. And that doesn't have to happen. These deaths are all preventable.
Question here for Dr. Pershing. This is from Delger Urdanesana at the New York Times. It has to do with some recent scientific speculations that in addition to climate change, the Tonga volcano eruption and also the recent drop in sulfur emissions from shipping have contributed to this year's extreme heat around the world. I think I just saw a Seth Borenstein AP story about this yesterday or so. Can you weigh in on the debate about whether these are significant contributors or not?
Well, I'd say, the jury's still out. That's something that certainly you could analyze in some of the in the climate model. So I don't actually know if I could make a comment on that at this point. I mean, I do know that you look at the climate statistics and the climate models, and this summer looks like the summers that people were predicting back in the 1980s, that if we had high CO2, we would be looking at these kinds of events all over the world. And so that I think that really speaks to this as first and foremost, a climate problem, right? A climate change problem, too much CO2 in the atmosphere. And I would suspect these other things may be contributing on the margins, but that the big factor is just way too much carbon dioxide in the atmosphere.
And Andy, do you want to talk about El Nino?
Sure. I mean, El Nino is just getting started. And it's, we're seeing high sea surface temperatures in the Pacific. That's the hallmark of El Nino. El Nino is going to boost global temperatures. But if you look at historically, global temperatures, right, the average over the whole planet, start to peak about 6 months after you start to see El Nino kicking in. So what we're seeing this summer, we are not yet even feeling what El Nino is.
Wow, I have not heard that, and that is a scary thing to hear. Thanks for adding that. Here's a question from Caleb Radel at KUNR Public Radio in Reno, Nevada. Extreme heat is far deadlier than other natural disasters. Why isn't extreme heat on the list of disasters eligible for assistance from FEMA, and should it be? Anyone want to jump into the policy world here?
It's an excellent question. A question I often ask, which is similar to this, is, for example, during the Pacific heat dome, 800 to 1,000 people died who didn't need to die. And yet these are never called mass casualty events. And they are. Look at how many people die in these extreme events, but they're just not framed that way. And part of the challenge, and it goes to one of the questions in the Q&A, is that to know how many people died from the heat requires a pretty lengthy process. That somebody dies, somebody has to sign off on a death certificate, eventually gets to the state level. It has to be coded using official coding approaches. It then ultimately goes to the federal level, and it takes about a year before you can do the analysis of how many excess deaths occurred. And so we don't know real time how many people are dying. We can figure out real time how many people died from heat stroke that you can get from the emergency departments in most cases. But it just is this long period before you have a real solid estimate of how many people died in these events. There's a paper that was just published about deaths from heat last summer in Europe. This is a whole year later, and the estimate for the heat in Europe last summer was about 60,000 deaths across Europe. So the numbers are really large, but they're not real time. And that doesn't help with the reporting, other than saying these numbers are really undercounted.
Mm-hmm. This is, I think, more of a personal reflection and a little bit of how I have dealt with heat over my life, and also just watching how it played out in society. I think there's a lot of machismo going on. A lot of people are like, yeah, I can handle the heat. It's always been hot. I know I'm a tough guy, especially guys, like I can handle it. And so I think we've put that on society, that this is something that you can just, suffer through and man up and it'll be okay. And I think, the Corey Stringer Institute is, I think, a great example of why how that breaks down. And so it's great to see a larger awareness of heat and health and all of these things to help, protect kids and athletes, as they're training outside. And I think we have not expanded that to society.
And I think something that would help in that dimension, Andy, because it's something that we both talk about quite a bit, is people will say, oh, I was part of this heat wave 5 years ago, but they don't remember the temperature 5 years ago. And so they don't really think about, I did okay, I'm now 5 years older, and the temperature was nowhere near as hot as it is now.
And I think this summer, it's how long they're lasting, right? It's like, you look at Florida, it's like more than 6 weeks at these unusually warm temperatures. Same story in the Southwest. The length of the heat waves, the persistence this summer, I think is the real story, even more than the absolutes that are getting hit.
Claire Carlson from the Daily Yonder asks, what legislation are you all paying attention to that could implement safety measures regarding human health and heat? On the state or federal levels, or anything of interest that you folks are tracking?
Both NIOSH and OSHA have work going on about heat and worker health. And as I mentioned, heat.gov has got quite a bit of information from the various federal agencies because they're coordinating now in ways they didn't in the past. It was NOAA that talked about the weather, but we've also now got FEMA, we've got CDC engaged. And so we're seeing greater collaboration through the National Integrated Heat Health Information System. And so these are really important advances to have the information of what you could do with regulation at the local level. So I do think that there is movement that's quite positive. And of course, it's been quite positive that the president has talked about the risks of heat just within the last few days.
Yeah, there's actually another question here that's maybe builds on that. This is from Michael Crow, who's a freelance reporter in Seattle. We talked about state heat protections. He says, can you speak about your thoughts on a federal standard? Is there a growing need for some kind of federal standard for health, safety, and heat?
It's a very good question. And one of the challenges we haven't talked about so far is that we are all to some degree acclimatized to our local weather patterns. And I like to make fun of Seattleites saying, if you transplanted all of us to Arizona, we just couldn't do that. we just couldn't survive. Eventually you acclimatize. And so thinking about national standards is really challenging because there are these very varied experiences. What I think needs to happen at state and the federal level is, I'll use Washington State as an example. Seattle, King County developing heat wave early warning system. That's great. I think Spokane's doing one as well. Someday Bellingham's going to do one. And we don't want to have every community start from scratch. What's the phone number? Who do they reach out to at the state level to say, what worked in Seattle that you think could work up in Bellingham? And so that you can have that knowledge transfer. And then similarly, across all of the states, just because I work in the space, I know there's a huge amount of work being done in Phoenix to reach out to the unhoused. But I can imagine that lots of people don't know that. And you can imagine a community setting up an early warning system and trying to figure out what to do about their population of unhoused. And you need something comparable at the federal level where you can say, can you tell me what people are doing about the unhoused in different places so I can see what might work in my particular location? And so thinking about the opportunities at the state and the federal level for much greater knowledge transfer, collection of best practices, lesson learned. And so that the ramping up of early warning systems can go much quicker. And again, we just don't have to all start from scratch.
And if I could just jump in on the early warning systems, I think this is something where the National Weather Service and the Center for Disease Control are starting to do some really great work that gets it. I think what some of the things that Chris was highlighting about the fact that heat vulnerability is local and it's also personal. It differs, from person to person, which is one of the challenges. So they have some great resources that they're starting to that they've been piloting in the Western U.S. that's going to get rolled out nationally. I forget exactly the timeline on that, but it will take this much more locally specific and a very objective way of identifying when heat is likely to be stressful for people and allow people to sort of see themselves a little bit more in the data and see, think more about their personal risks. And I think that's I think a big challenge for heat is that it has that nuance in a way that, a tornado or a hurricane doesn't. And I think you're starting to see more tools that can help people make that connection.
As a former Fed, seems like a perfect job for the federal government to get on top of. So I'm glad to hear there's some progress going on there. We've got time for a few more questions. We've got some great questions here lingering that I want to try to get to. And this one for you, Dr. Pershing. Andy, can you speak more to the issue of plants and botany having to adapt to heat that you mentioned and the lack of this coverage?
Yeah, thank you for asking that. I'm going to put on my marine biologist hat. I'm actually an oceanographer by training. I don't frankly know that much about plants. I know a lot about coral and fish and things like that. And that's what, that's the next big thing that we're going to see around the world is this, the mass coral bleaching. Like it's already started in Florida and the Caribbean, and we're going to see that pop in the next year. I mean, it's tragic. And on land, we're also seeing these large scale, ecosystem transformations. The most visible one is a forest fire, where that is the ecosystem trying to, in a way, drive from a forest towards something like a grassland. But I am really interested in this. I would love to see more work from the scientific community. I would love to see more more discussion of what are the ecosystem impacts of heat. What does it mean that it's warmer at night in so many places, and night times are warming faster than daytimes? What does that do to the insects and plants? So there's lots of work needed in that space. But it's more like, I think there are stories there, but I honestly don't know what they are at the moment.
I would encourage reporters to come to us at SciLine if you're looking for experts who really specialize in that. I'm sure we can help in that regard.
Great.
Question here from Shannon Kelleher from the new lead. Do you expect El Nino's effects, since this came up, to begin showing up this winter? And what kind of impact do you think it may have on winter temperatures? And are there any U.S. regions that it may affect most, and how should people prepare?
So that's a great question. El Nino, if you go to the NOAA websites and you start to Google around and what you should expect from El Nino, you will find a lot more maps telling you what the impact is in the winter. And unfortunately, I don't have those on the top of my head, so I'm not going to answer that question and mess it up. But there are great resources out there, and that's certainly the time when I think we do expect that we will start to see that. Right now, the main effect that El Nino is having is it tends to increase the winds across the Gulf of Mexico and South Atlantic. And that tends to suppress the formation of hurricanes and tropical storms. Doesn't mean that that we're not going to see hurricanes and tropical storms, but it's the reason that we can have really extraordinary sea surface temperatures. And and NOAA is predicting, I think they just updated it today, to just a slightly above normal hurricane season.
Great. One more health question I want to squeeze in for you, Chris. I know we're going to have to stop on time at 4 today. And by the way, I want to encourage reporters, when you do log off today, you will get a prompt for a very short 30-second, 3-question survey. Please take the half a minute to fill in that survey. It helps us do a better job on these briefings. But from Penelope Overton at the Portland Press Herald in Maine, could you talk about the role of humidity? Have we seen extremes in this area too? Does climate change have its fingerprints on this variable? What are the health impacts of high humidity, even if the temperature increase in an area is only moderately higher than normal? So a mix of things there, but do you want to tackle the health angle there, Chris?
We know humidity matters, and we know that there's places in the US that have much higher levels of humidity, and we all know what we feel like. I'm not somebody who does well in high humidity, so I know what I feel like when I go to hot, humid places. I know people who love humidity, but it is much more stressful for our bodies. And many places look not just at temperature, but they look at apparent temperature or humidex or a number of other indices that take into account both temperature and humidity and give you a metric of what it feels like. And the feels like includes that aspect of humidity. And physiologically, we know that it matters. It's much more difficult for our bodies when there is high humidity. We also know the converse, when you think about all the coverage of Phoenix, that very low humidity restricts the number of options for trying to cool ourselves down. One way is to sit in front of an electric fan, spray yourself with water. We know if you walk under a mister, you feel cooler because of that evaporation. But it's so dry in Arizona that the water evaporates too fast, really, for there to be much of that cooling effect. And so we need to pay attention to both the very low and the very high in terms of trying to protect the population.
That's
Andy, you want to
fascinating.
talk more about humidity?
Yeah, I mean, just to bring it back to climate change. So a warmer atmosphere can hold more water vapor. Okay. And so what that tends to do is that's going to increase the humidity generally, but especially if you're someplace where the air gets to pass over a warm ocean, right? And so now you have a source. And so that's a big part of what we're seeing in Florida right now, where they're having not only really high temperatures, but also really high heat index values. So the humidity there is also really high, especially for the temperatures that they're getting. But that increases then the potential all over the country for extreme rainfall events. So the big rainfall event that we had in Vermont a few weeks ago, those sorts of events where you're getting like 2-3 inches of rain, over a couple of hours, those are hard to imagine getting at the, outside of a tropical storm in a world that doesn't have an atmosphere fueled by greenhouse gases.
Okay, we are just about out of time, and I'm sorry I didn't get quite to all the questions. We might try to connect a few of you afterwards, but I want to leave the last minute or so for our experts here just to take a half minute each and give the reporters on the line here sort of one take-home message. If there's one thing you want these folks to walk away with today, really having high front of mind as they go about their reporting on this beat, what would it be? Andy, I'll start with you.
Yeah, I think this is not normal. This is shocking. But it's not surprising. It's what was predicted, 20 or 30 years ago. So, it's not normal. It's not a new normal. This is the world we're living in. And part of that is acknowledging the change, that things are, unfortunately only going to get harder as the years progress until we get CO2 under control.
Chris?
Heat-related deaths are preventable. People should not be dying in the heat. And it is really important for the media to cover this story, because we need to raise awareness so that people know that they have to take action. They've got the motivation to take action. So thank you for the coverage that you have, and continue to emphasize people don't need to suffer and die in the heat. We've got ways to manage that much better than we're doing today. And it's critically important, as Andy said, to invest in that so that our future doesn't become more dire.
Great. Well, I want to really thank the both of you so much for all the expertise you've brought to this session today. I want to remind reporters on the line that we have other media briefings coming up over the next few weeks, including one in about a week about what's going on with regard to the revolution of using psychedelic drugs as therapies for various conditions, which is going to be fascinating as well. So we hope to see you there. Check it out at SciLine.org. Follow us on Twitter or on X at Real SciLine. And we look forward to helping you reporters as you continue your work on this super important topic. Thanks. See you next time.